Hello and welcome everybody. In this brief tutorial, I'm going to give you a basic introduction to WUFI Pro 6.2. If you're not familiar with WUFI, it's actually represents a range of simulation software that's been developed by Fraunhofer Institute of Building Physics, abbreviated IBP in many instances, and it can be used to calculate transient heat and moisture transfer in building components and assemblies. When I am working on a project and I get a question about condensation risk and dew point related issues, this is one of my trusty go-tos. I'm going to give you just a very basic introduction here on how to build a wall assembly, how to essentially define the layers of the assembly, and do a basic simulation run to understand the interplay of heat and moisture. So what you see on the screen here is the default window when you open the program. You can see along the left-hand side project, you can uh, define your case number. This is your actual case by default, case number one. The idea is that you may have multiple cases. You may have a baseline case, different design options. And I'm going to just create a basic project here, project name. I'll just call it example residential project. And client is a residential owner. You can put in whatever you want. We're going to put this in, I'll say Indianapolis, Indiana, and zip 46204. Okay, and you could fill out the rest of this if you want. I'm not going to take time here to do that, but it gives us some basic info. And as you look here, you can see three menu items, sort of three different spheres of information that we need to define in order to run a simulation. So I'm going to open all three of these up. And you see initially a red check mark, red for stop. That requires some attention. And we're going to turn all of these green in a couple of minutes and run a simulation. So I'm actually going to start down here at climate. We want to define our outdoor climate condition and our indoor climate condition. So for outdoor, I'm going to use this first tab from map or file. I'll select a climate and I mentioned Indianapolis. So you can zoom in, rotate this around, look in this database to find weather stations in a wide range of locales. But I'm going to pick Indianapolis here. And so I am going to zoom in just a little bit. Indianapolis, there I have it selected. And again, you could switch around to different regions, different continents. I'm going to stick with North America here as I'm doing a North American-based project, Indianapolis. And then notice here, you can actually pick from a few. So if you have a hard time selecting through this viewer, you can select it through the drop-down. And then here you can specify if it's a representative cold year or warm year, or an ASHRAE representative year 1, 2, or 3. And I'm going to stick with a cold year. And that is essentially that for the climate. I'll hit OK. And here you can see it imported climate data for Indianapolis. It gives you some basic information that you can assess, you can evaluate. Let's go down a little bit here. You can zoom in and out. I am then going to go to indoor climate, and I have a few options, and that would be represented by the rest of these tabs here. This is a European-based standard 15026. I can go with this ISO International Standard 13788. The sine curves, but I am going to go with ASHRAE Standard 160. I'm going to look over here to the right. Heating only. I did pick a representative cold year, but Indianapolis, we are right in that climate zone, that ASHRAE climate zone 4-5 RIP band. I'm going to go with air conditioning. That's going to set parameters for both heating and cooling. And then you notice here some specifics that we can adjust. And as I look at this, I can see my degrees Celsius. So that is reminding me that I should go up to options and unit system. And for me, I'm going to pick inch pound system of units and hit OK. And it'll give you, if you've already input a lot of data, you will want to heed this warning about just some possible rounding errors, but I'm gonna hit OK because I am just getting started. And now you can see here things like the set point for heating and set point for cooling. It did adjust degrees here from Celsius to Fahrenheit. So I'm just going to round this out to 70. I'm going to round out the set point for cooling to 75. And then I am going to acknowledge down here my air exchange rate. This is based on the looseness or tightness of your construction. You can get into specifics, or by default, you could select standard construction or airtight construction. I'm going to go with standard construction. Noting my building volume here, 17,657 cubic feet. I will keep that by default for this example. And you can now see on the left-hand side under climate, I now have outdoor and indoor defined. Okay, so now I'm going to go up here to component and I'm going to look at my assembly. And right now you get a window that looks like this in a big gray rectangle. We have not defined anything yet. I'm going to go to my material database and I'm going to assume right now I'm going to define a basic residential wall assembly. So when I go to define my initial layer, you can see the WUFI material database, and uh, you can look at the packaged IBP material database. You can see generic materials listed, a Japanese database, there's a North American database. And so be mindful of the database that you're drawing from. There's some manufactured uh, products, some specific product data in here, but there's also some uh, industry-wide representative materials that are defined in here as well. So I'm going to go with a bat insulation infill. So I'm going to type in bat and you can do a word search that way. And I can see Rockwool Comfort Bat. But I also see through the North American database a generic low density glass fiber bat insulation. I will select that and hit assign. And now this changes color. And you can now see this is yellow representing that material type. Notice that the right-hand side, I'm essentially creating a vignette in section view of my wall assembly. So interior to the right, exterior to the left. And right now we have our 3.5-inch thick insulation layer. I'm going to actually assume this is perhaps 6 inches thick, and you can define it that way. Now I'm going to add a new layer, and another gray rectangle shows up. Go to my material data, and on the inside here, I'm going to say this is gypsum. So I can start to type in gypsum, interior gypsum board, North American database. That's good enough for me in this example. I'll hit assign. 0.49, I'm just going to round that out to a half-inch product, and that is now defined. Okay, I'm going to add a new layer, and this one throws it outboard of that gypsum board. I'm actually going to drag this over to the left, and I'm going to define an exterior sheathing material. So I'm going to go here. I'm going to look at plywood, and I'm going to look at my North American database, plywood exterior grade. That is good enough for this example. I am once again going to round this out to a half-inch. So that's been defined. And I'm going to add another layer and drag it to the left because I need exterior siding. So I'm going to go to my material database and here at wood siding. Now, I will admit I am considering a cut through my bad insulation layer, my infill between studs. I'm going to look here at, let's see, some kind of siding. Let me just type in, maybe go with a composite siding. I'm gonna type in, oh, there we go. Started to type it in, North American Database, composite wood siding. I'll go with that. And so you want to hover your cursor over, make sure that everything is in the right order. Now, what I have not done yet is added anything to impede the flow of vapor. There's no air barrier. Well, I have a dedicated thermal barrier. I don't have a weather resistant barrier at all. So let's go ahead and add those. I'll say new layer, and I know this is going to be my weather resistive barrier, so I'm going to drag it over to here. Okay, I am going to go to material data and just type in weather. So weather resistive barrier. This is from the IBP database. I'm going to assume this mid-range material for the ease of this example. You can see it represented there. I would need to do some due diligence here to look at its ability to serve as an air barrier. I'm also going to add one more layer here, and let's actually, I take that back. I might actually just, yeah, you know what? Let's go for it. I'm going to look at some kind of a vapor barrier here. So vapor retarders, we got different options. I'm going to scroll up. I want to look at my perm ratings here. Hmm. I am perhaps going to go with a very resistive zero point 0.1 perm. Actually, what would make this for an interesting example? Let's go with a zero point 0.1 perm. I'm going to select that. Okay, there it is. Okay, warm side of my insulation in the winter time would be on the right-hand side, but I am going to throw it over here to create an interesting example for us here. So I now have to recap from outside to inside. I have my composite wood siding, weather resistive barrier. I've got my plywood exterior grade. Now I have a vapor retarder zero point 0.1 perm. Just behind that, I have my low density glass fiber bad insulation, and then I have my gypsum board. Okay, we're ready to do a simulation. Insofar as that assembly definition goes, let's go to our next items here. Orientation. So your wall assembly is going to perform differently based on location and also orientation. I'm going to give it some sun exposure by making this face south. So there's that. Uh, Based on how it's oriented relative to its inclination, I could make this. This is when you're looking at maybe a sloped assembly. You may want to work with this. I mean, you could give it about any slope you want. I'm going to maintain a vertical wall situation, and then I need to define my building height because that will start to influence the driving rain coefficients. Uh, I can select from a few different options here. You could assume a tall building and look at an assembly that's located more than 66 feet off of grade. I'm going to actually just go with this short building height up to 33 feet. That looks good to me. Okay, orientation is done. Surface transfer coefficient. In this tutorial, I'm not going to adjust any of this for basic access into the program to really just get familiar, have a point of access to start to learn the program. I'm going to say, as is the case with many building performance simulation programs, leave the defaults in unless you really know what you're doing, and I will do that here. Initial conditions. This is important in the sense that the simulation, when it starts and it goes through a 3-year cycle, it's going to have an initial condition with regard to humidity and the initial temperature in the components. So I'm going to go with this 68 degrees Fahrenheit and this zero point 0.8 relative humidity. I'm going to knock that down to 0.6. And okay, now my components are defined. I'm going to go to control, calculation, period, slash profiles. It's going to give me 3 years. It's indicating it here, the start and end of the calculations. You could tailor this as you wish. And then this last tab here, you can go in and define some additional information on the numerics. I'm going to leave that where it is. We are ready to go. We've got our wall assembly for this first case. I can do that 3-year run just by clicking this button. It's going to run the data. This is going to go pretty quickly, but it's not going to give me any kind of dynamic visualization. It's just running the analysis expeditiously in the background, and then it's going to give me my output reports. So I'm going to do this here. By the way, everybody, as we're waiting for this, once you have your wall system or whatever assembly you're working on, once you have it defined, you can look down here at the bottom and see total thickness, total thermal performance, the total R value, and the U value of that assembly, which is great information that you'll want to bring back to your project team. Okay, so our simulation is just about finished. And there it is. So it finished this off. It's got some data that you could examine. I'll close this. It also added this new menu option down here, this quick graph menu. I can look in here at things like total water content. You can look at, and there's over my 3-year run. This is showing me that during late spring, I have a lot of water content in this assembly. You could get into the water content on a per layer basis and examine that. You can get into exterior surface and interior surface data. And there's a lot of great information that you can examine here. I'm going to close this up. I am going to go back to this component, and I'm going to go to another tab here. By the way, if you have multiple cases, you can run them all at once, so you can process the entire simulation in one shot. You can also take this third option, run calculation with film. So I'm going to click this, override results, yes. It's going to bring up a window that looks like this. I'll maximize this window. I'm going to go into properties here and check a few things. I do like to go to the dew point, make sure that that is visible. Sometimes the default menu might not have that checked. I'll apply, hit OK. And so this is my wall section. And you can see a few things set up here. This red would be the temperature, degrees Fahrenheit. You can see the scale. This purple represents that dew point. When this is giving you a thermal gradient, once we activate the simulation, and you'll see the fluctuating thermal gradient, you'll see the fluctuating dew point, you'll see the direction of thermal drive, the way that heat wants to flow on a per component basis. And then down here at the bottom, this is your moisture chart. You'll be able to see on the left side in dark blue, the water content, pounds per cubic feet. On the right-hand side, relative humidity in green. And this will give you some definitions of these layers and their general widths in case you wanted to quickly recollect that. So I'm going to hit play, and this will begin my simulation. And again, you can see how this is working dynamically. The red showing you on a day-by-day basis the direction of thermal drive and moisture vapor drive, how it'll actually act differently based on if it's a sunny day or if there's a rainy day and it's receiving moisture. It'll go through. I can increase the speed of this, make it go a little faster. So now we're getting into the next month, November. And I'm starting to notice something here, everybody, as we're getting into mid-November. Look at this. This is where that vapor retarder was located. This is my bad insulation. This is my wood siding. I'm sorry, this is my wood sheathing. The siding is of course on the total far exterior side. But notice behind my sheathing, I am starting to have bulk water accumulating. And now I'm into late December. Now I'm into January, the middle of winter, and I have a very real bulk water issue starting to reveal itself just behind my wall sheathing. So this is concerning, and this has to do with the assembly not being able to dry at this location. So while moisture can drive one way or the other, I do have my weather resistive barrier, and I do have my vapor retarder located here, and it was a zero point 0.1 perm product, as you may recall. So now we're into February, going into March, and you can see what was indicated in one of those charts I showed a few minutes ago. This is accumulating, and this looks like it could be a big problem. Let's just crank this thing up speed-wise. I'm into May. I'm getting into June, and notice by June, by the summertime, it does start to dry out. But by that time, you have had multiple months with considerable bulk water accumulation, and likely damage has already been done by the time we get to a cyclical period of drying. So now we're into August. We're just about around the clock now, almost back to October again. Uh, for this tutorial, I'm going to stop it here. I think I've seen enough. Let's see if we can make an adjustment. And by the way, it'll give you all your quick graphs and information outputs. Let's make some adjustments here. This vapor retarder, let's get rid of that. Let's instead add a new layer just behind the gypsum board. Let's go into my material data. Let's go back to searching for vapor because I saw a product a few minutes ago that I think I liked, this 3M vapor permeable air barrier. I'm going to select that. I'm going to assign it. I'm going to keep it on this side over here. So it went to, where did that go? Wasn't that one? No, that wasn't it. Oh, you know what? I'm sorry. Let me put that back over there where it belongs. It's that right there, that white one. I was looking for blue. There it is. There's my 3M product. Okay, so we have another run here. I am going to just fire off and do it again. So let's see what we get. Override data. Sure. Let's see if this behaves in a different way. So properties, again, I like to go in here, check, make sure I got my dew point. Okay, all right. All right, so here we go. Let's maximize this and go. Let's see what we got. I kind of know the story a little bit here. Let's crank this ahead. So now we're getting into January. This is where we started to see issues, and I am seeing some bulk water building up, but it's still building up quite a bit. Hit this button, it's starting to move. It's not accumulating quite the same way now, is it? It is considerably less. So we are allowing the potential for drying to happen here. It's building up a bit. But you see by March, when we had that peak, this is no longer going off the chart. It is fluctuating, but that is not necessarily a concerning amount while we are allowing drying potential to happen. Now we're into April, we are into May, and we are now into June, the summer months. And you can see while it did start to precipitate a bit, we did allow drying potential to happen by shifting this vapor retarder from this part of the assembly, just behind the exterior sheathing, to just behind the gypsum board. On this representative cold year in Indianapolis, we can see that we have thwarted our emerging condensation concern. You can see that there is a healthy band maintained between the thermal gradient, the red, and the dew point temperature located there in purple. So as I look at this, I feel much better now. This is into just about the end of year one. I'll crank it ahead quickly here. This is year two now. And I could go through all 3 years and see if, okay, so there's my winter accumulation again. By January, we get to February. Before, by March, it started to die back out. Now we're into March. This is of, oh, and then it starts to go away again. So I'm feeling pretty good about this. So I could let this simulation keep running. I will stop it here for the sake of our tutorial. You can see these residual bands that indicate on the humidity side and on the bulk water side just how much it ranged during our simulation that we allowed. I'm gonna hit close here. So you can stop it mid simulation like we just did. You can go back to your quick graph. You can look at information here and examine it just as we had been. But that, everybody, is a quick tutorial for WUFI. I hope it created a point of access for you to get into this program and start to use this, get familiar with it. There's a lot of information that we're not going into in this tutorial. I'm just giving you the basics so you have a point of access. so it seems less intimidating. So you can go in and start learning. But jump into WUFI. The water's fine. It's a tremendous program, one of the best in the market to look at condensation risk. And I hope that this tutorial was useful to you. So thanks, everybody, and happy simulating.